Assalamualaikum warahmatullahi wabarakatuh. My name is Hafid Rai Mufti. I am from the Department of Mechanical Engineering, 11 Maret University, Indonesia. It's great to be here to represent my article at the 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering. In this section, I will talk about my article. The title is The Effect of Quenching Agents on T6 Heat Treatment on Hardness Al6061-sea composite. In introduction, in the increasingly advanced world of the automotive industry, the demand for superior materials that have high mechanical properties, lightweight, and have low operating costs is increasing. For example, in the piston, connecting rod, brake pad, and swing arm components, currently the material used in the manufacture is metal matrix composite (MMC). One of MMC's products is IMC, aluminum matrix composite, whose main material is aluminum with ceramic reinforcement. The aluminum used in this research is Al6061, with the main alloy is MgSi. The 6 series aluminum is usually used in the automotive industry because it has superior mechanical properties, including lightweight, good formability and wettability, as well as good corrosion resistance. While the reinforcement use C-sand, which contain ceramic compounds that can be used as a substitute for a ceramic powder to reduce production costs. The composite manufacturing process uses a simple method, namely stir casting. Stir casting is a process where the matrix material is mixed with reinforcing particle in a melting condition, which is then stirred to form a vortex to combine the matrix and reinforcement mixture so that the particle distribution is evenly distributed. Aluminum 6061 has a weakness in terms of strength. One of the methods used to increase its strength is the heat treatment. Previous research explained that the heat treatment with a cooling rate of various quenching agents affect the mechanical properties of the material. The faster the cooling rate, the higher the strength of the resulting material, but also distortion and crack. For this reason, it is necessary to determine the optimum quenching media so that it can produce maximum mechanical properties on the Al6061 season composite. In Chapter 2, I will talk about materials and method. The matrix used in the study is Al6061 with the main alloys being Mg and Si. For the reinforcement, we use C-sand, which is treated with an electrous coating. The steps of the electrous coating process are: add 40 ml of HNO3, 40 grams of C-sand powder, 0.5 grams of IL-fine powder, and 0.1 grams of Mg powder into a measuring cup, then stirred using a magnetic stirrer, and then heated at 80 degrees Celsius for 30 minutes. Then, the results of the electroscoating process are put into the furnace to be dried at a temperature of 200 degrees Celsius for 60 minutes. Then the temperature was raised to 400 degrees Celsius and held for 120 minutes. After that, it was cooled to room temperature. And the wetting agent used is magnesium powder. The method used in this research is stir casting. The stir casting process is carried by melting Al6061 into the furnace at a temperature of 750 degrees Celsius. Then, adding 4% Wt of electro-coated C-sand and 1% Wt of Mg powder as a wetting agent into the stir casting furnace. Stirring process is used a 4-blade impeller at a speed of 600 rpm for 10 minutes and then poured into a permanent mold that has been heated at a temperature of 500 degrees Celsius. The heat treatment method is T6, consisting of solution heat treatment, quenching, and artificial aging processes. In the solution heat treatment process, the specimen heated at a temperature of 540 degrees Celsius for 6 hours. Then continued with the quenching process with three variations of quenching media, namely oil, water, and 10% salt solution, and continued with the artificial aging process by heating the specimen at 200 degrees Celsius for 4 hours. There are two material testing, namely hardness and density testing. Hardness testing is carried out using the Brenner method, which refers to ASTM-E10. This hard test uses the control diatester 2RC control Paris French. The indenter used is a steel ball with a 2.5 mm diameter, 62.5 kg load, and 30 seconds loading time. Density testing is carried out using the ICIMECE method with fibra scales. The composite density is calculated according to equation 1. The porosity calculation can be determined by comparing the actual density with the theoretical density using equation 2. This is the table of notation of Al6061-sea and composite specimen. No reinforcement and non-heat treatment called ingot. The non-heat treatment called NHT. Heat treatment with N oil called HTO. Heat treatment with water called HTW. And heat treatment with brine called HTB. And then the next discussion is result and discussion. First, I will talk about the density of the composite. The density of the composite that was heated treated with variation in quenching agents did not show a significant difference in value as shown in figure 3. This is because the heat treatment process does not affect the density value. The theoretical density value for each variation of quenching agent is the same, 2.699 grams per cc. The similarity of the theoretical density values is due to no change in the wake friction used in the composite material. And the next is porosity. Figure 4 shows the percentage of composite porosity that occurs in each variation of quenching media does not change significantly. The porosity results obtained are proportional to the density because the porosity is obtained based on the density result. The porosity that occurs can be caused by gas trapping during the jet casting process, hydrogen evolution, and during different solidification processes. And then we go to the discussion about hardness. The results of hardness shown in figure 5. Salt solution or brine has the highest severity value compared to water and oil, which is 2.0 to 2.2, while water has an H value of 1.0 to 1.1, and oil has an H value of 0.3 to 0.5. The higher the H value, the higher the cooling rate and the higher the hardness value. When specimens were cooled with brine, the resulting precipitate phase was smoother and more homogeneous, resulting in higher resistance to dislocation movement. To lower cooling rate also affect the amount and size of precipitates. More and smaller precipitates cause an increase in the hardness. In the end, we come to the conclusion. Heat treatment with the same wake fraction of reinforcement does not affect the density value. Heat treatment of T6 with oil, water, and brine quenching agents can increase the hardness value of the Al6061-sea composite. The higher cooling rate of the quenching agents result in higher hardness values. Quenching agent with brine resulted in the highest hardness value. The lowest hardness value was obtained by using oil quenching agent. Thank you. That's all of my presentation. Thank you for your attention.